Welcome to another episode of our new Mint NFT application. Um, on the last episode, we created the API that will receive the files and we will create the NFTs, images, and metadata on the IPFS file system. For today, we will concentrate on creating an NFT smart contract using Solidity for the Ethereum network in Ethereum blockchain. And for that, we will be using Hardhat. Hardhat is a set of development tools to build an NFT. Sorry, to build Solidity smart contracts. And let's check it on the tool. The tool name is Hardhat. So we go to the website Hardhat Ethereum, and here it is. I will put a link on the description for this. And as you can see, it allows us to run Solidity locally, allows us to debug our smart contracts. We can bring our own tools in terms of extensibility. That means that we can use OpenZeppelin imports here. A lot of plugins. I particularly like one plugin to allow us to calculate gas fees. That's really helpful. And we can use TypeScript. Another thing is that we can test extensively our smart contracts. That's a very important thing. And it has a very large community. It has a Discord. I would recommend that you join it. And let's get started. Let's check the getting started steps. So for running this, to initializing a project, we will use the terminal, the CLI, and we need to run the npx hardhat command. We can also install Hardhat as a dependency of an existing project. You can use npm or yarn. In this case, I will use yarn. So we have to check in the installation. It will ask us if we want to install all the dependencies using npm. We should hit no and then run to proceed to install the dependencies using yarn. So the first command it will be to create a folder for our project. So mkdir mint nft contract. So in here, npm hardhat. Okay, so our choices are create a basic sample project, an advanced sample project, an advanced sample project that uses TypeScript. This is the one that we will select, or create an empty hardhat config. So let's select an advanced sample project that uses JavaScript. Project root, exactly the same folder. Do you want to add a git ignore? Yes, because we are committing this to GitHub. And this is the step that you want to skip. Do you want to install the sample project dependencies with npm? We will select no. Since we selected no on the npm step, we will need to manually install the dependencies. So we can pretty much copy the list of dependencies and then use yarn to install them. So I would do yarn add and paste the list of dependencies. And we will add one more dependency here, and that's OpenZeppelin. So OpenZeppelin, as you can see here, is a library that has a lot of smart contracts already pre-built. Implements a lot of standards like ERC20, the token standard, ERC 721, that's the NFT, is an NFT contract. One of the contracts that we will be using is the 1155, and it's also implemented in OpenZeppelin. So I will add this dependency to our contracts, and we will see how ERC 1155 works. So let's add one more. It's OpenZeppelin contracts, and let's run that. So now it's installing all the dependencies. In the meantime, let me show you how our contract will look like. So this is an ERC 1155 is a multi-token standard. That means that with a single NFT contract, we can deploy several tokens. And in the case of our application, every NFT will be a different token with IDs going from 0, 1, 2, etc., depending on how many NFT we create. And the contract will look pretty much like this. This is a Solidity contract that extends the ERC 1155 contract from OpenZeppelin. As you can see, we only need to create a constructor. Of course, our NFT's ID will not be hard-coded like in this contract. And in the mint, we will dynamically mint depending on how many NFTs the user creates in the interface. And the URL of the metadata will not be hard-coded like in this case. It will be passed down to the contract, the deployment, using the IPFS address where we store the JSON metadata, right? So this is pretty similar with what we're going to do. Actually, we can pretty much copy paste from this contract. I will leave this page open right here so we can reuse this on our contract. So let's wait for this to finish. I think it's almost done. And almost there. There you go. Now we have all the dependencies installed. Now, one of the things that I will do is to add, we can call yarn hardhat directly, right? And we can pretty much do anything that we want using that command. We can compile, we can open a node, open a console, run some script. So that's the way we will call it from the terminal. You can also use npx. The problem with npx is sometimes it's slow because it will try to download the dependency and then run it. And since we already have a project that's a hardhat project, we can just do yarn hardhat, right? So let's open the project that we just created. Here's the project. And in the project, we will see that we have a contracts folder with all our smart contracts. We have a script folder. Initially, only have the deploy script, and we have a test folder with an initial test for that sample contract. So we will create our new contract here, and let's call this min NFT sol. And since we already decide that our contract will look pretty much like this, let's copy this, right? And let's use that as the base for our smart contract. So of course, this is the mint NFT contract. We will be using another version of Solidity here. We will be using 0.8. And it's not gate items, it's mint NFT. We don't need any of this gold, silver, etc. And we don't need this mints, right? So yes, it's an ERC 1155. Now we need to set up a set of parameters in the constructor. I think one of the first parameter is the URL where our metadata will be stored. So let's call this string memory URL, and we will pass that URL to the ERC 55 initializer, right? Now, the second parameter that we need to specify is the quantities. Remember, the smart contract in a token in an ERC 1155 will allow us to create different quantities for each token. So in the case of our tokens, the quantities are described in the in the in the metadata that we have in the UI. And so for that, we will have a new variable here. Let's call it new integer 256 array memory. Let's call it quantities. So these are our two parameters. Yes, of course, we are not using quantities yet, but we will use it right now. And we will do a mint inside here. So basically what we're going to do is we will create a loop through all these quantities, and the IDs will be 0, 1, depending on the number, on the index in the array, and we will mint that token with the number, and we will mint the amount of token that we need for that that the user specified for that token, right? So let's do that. Okay, so we will iterate on the quantities array. Let's create an index for the array. That will be the variable I, and then we will basically get the length of the array in another variable. Quantities length, and then let's make a loop. So we will make a loop for I in I length. I think we can do this, and we can then mint using the sender. So the token that we will mint is I in quantities, and then we will put some empty. Okay. And then we will do this uncheck, and we will do plus I. So this is our one more thing that we have to remove here is this public modifier, because constructor don't need that, and now we have our function. The other function that we need to create on our contract is the URI function. This function will be overriding the ERC 1155 function that OpenZeppelin creates because we want to append the token ID at the end of the function. So let's override the function. The function is URI, and the parameter is uint and uint 256 and the token ID. So we can do token ID, and this function will be public. It's a view. It's an override, and returns string memory. Now, what we're going to return here will be a string, and that string will be the concatenation of the default function, that means super with the token ID, and we will use these strings import to string of the token ID. Let's see, we have our parentheses. There you go. Then we have an extra parenthesis. There you go. String. So we don't have strings. String is actually an OpenZeppelin contract that gives us some utilities. You can find it in OpenZeppelin. Let's see if we can find that. Probably in utils. So we have possible address counters. not here. Where can we find that? Let's try to search Open Zeppelin strings. Yes. Okay, so it's a contract, so we need to import it as well. So contracts, it's not a token, but it's in utils strings. There you go. Our contract, the way it's set up right now, it has a constructor that allows to specify the URL and the quantities. We mint all the tokens depending on the quantities. The tokens ID will be numbers, so 0, 1, 2, depending how many tokens how many NFTs we decide to create. And we already redefined the URI function to basically add the token ID at the end of the URL that we specify. Now a couple of more things that we should probably add in every ERC contract is first make it ownable. So ownable is another Open Zeppelin I would say extension that allows you to create a contract that has an owner. This is important because you can redefine functionalities in the contract only by the owner. So this is a type of permissions that you can have. I will try to import the owner ownable contract to make this contract ownable. So Open Zeppelin. This will be contracts. I think it's in access. And it will be in ownable. So now we can mark this contract as ownable, right? And if we set it ownable, I think one of the functions that we might want to implement is a function to change the URI. So let's create a function to set URI, and we will pass in memory URL, and this will be a public function, but it will be an only owner. So this function can only be implemented or be called, sorry, invoked by the owner. So let's call it like this, and this will allow us to modify the URL of the contract. This is important because the contract remains, but if we want to move the assets, like the metadata of the images of the contract, then the owner of the contract can actually invoke this function and change the URL to where the metadata and the images is located, especially the metadata. That's the reference that the smart contract has. The other contract that we want to use to extend this contract is the burnable. So we want to be able to, the users that have the accounts that have tokens for this NFT, to be able to burn their NFTs, essentially delete their NFTs. So let's import the Open Zeppelin contract that helps us implement that extension. That's an ERC 1155 extension. You can find that in this Open Zeppelin documentation as well. So this is contracts. This is a token, ERC 1155 extensions, and the extension is the ERC 1155 burnable. So we will mark our contract as ERC 1155 burnable as well. For this extension, we don't need to specify anything else. It will add 2 more functions to our smart contract, burn and burn batch, so you can actually burn your tokens. And this is our contract. Once we have the contract created, we can now compile it, right? And that's what we're going to do in the terminal. We can delete the other contract, by the way. We don't need it anymore. We'll just leave it for now. but since it's no longer necessary, you can delete it. So let's go to our terminal and let's compile our contract. So the command will be jar hat compile. It will compile all the contracts in the contracts folder. So it will compile our mint NFT and our greeter contract. There you go. So we compile the contract, and you can check the artifact folder that was just created. In that artifact folder, you will have one folder for the mint NFT, one folder for the greeter, and in that folder you will have a JSON file with the compilation of your mint NFT contract. This is a big file, of course, and it has the binary information at the end. So we will not be touching this, but we know where the contract is located, the artifact is located. We will be using this in the next episode when we will take that contract and we will deploy it on our application. For now, we just know that it's created here, right? So we got to compile our contract and no errors locally, and we will now deploy our contract. So we can deploy our contract directly to Ethereum. We can deploy to a test chain like Rinkeby, or we can deploy into a local network, a local node. That's what we're going to do, and we also will implement tests for this contract. So to deploy the contract, we have a script to deploy, and in here the default script is deploying the greeter contract. We will change this to deploy our mint NFT contract. So we can change here for this for mint NFT, and let's go this NFT, mint NFT. So I'm just changing the code. Now in this function, as you can see, the deploy, remember our mint NFT, okay, like we'll have to provide some data here, and we'll wait that it's deployed, and then we say, well, mint NFT is deployed to this address. So we'll get the address where the contract was deployed. And to deploy, so to deploy the mint NFT contract requires two parameters. The first is the URL. For that, we will just hard code a URL. So let's assume that we're passing an IPFS URL. Let's go some IPFS URL. And IPFS URL, we know that from the previous episode that our URLs for the metadata will have an NFT, and they will be dash and the ID of the token, right? But we will leave it there because remember our URI function will basically concatenate the URL and the token. So whatever token, so if the token 0 will be 0, 1, etc., and so on and so forth, right? And the second parameter is the array of amounts, so the quantities, right? So we will deploy one contract, one token for the first NFT, one for the second, two for the third, and three. So we will deploy 4 tokens, each one with these quantities, right? And that's our deploy script. To run the deploy script, we run also a command. Because since we want to deploy our script into a local node, so we can do some testing, like a console testing. We will run tests, but this is just manual testing that we were doing. Let's try to run a local node. And for that, hardhat has a command, jar hardhat node. It will start a local Ethereum node. And there you go. Now we have a running Ethereum node. We have 20 accounts that are created, and each account with the private key. So we can use these accounts into MetaMask if we want to. Like you can connect to the local network in MetaMask. You can connect these accounts. By the way, these are public accounts, so they're always the same. Don't never send actual Ethereum to these accounts because you will definitely lose them. Each account in this case usually is created with 10,000 ETH. So there's plenty of ETH for your testing. And let's open a new tab because that network tab, that node should be running when we want to deploy. And let's deploy our contract on that local node. So jar, I think the command is hardhat run script, and this is the command. Jar hardhat run scripts deploy VS into the local network. When we are deploying to other networks, we can configure hardhat to deploy to the main Ethereum network or to any test networks. So you can configure that there. In this case, we're going to deploy into the local network. So we can run this command, and this command will deploy our NFT to that network. There you go. So the contract was deployed to this address, and as you can see, there is already action going on in the node. See, contract deployment. This is the name of the contract. This is the address. This is the transaction. How much gas was used. Okay, perfect. Now we have a running contract. Now, if we want to interact with that contract, we can run a console. So jar hardhat console into the local network. So let's do that. And here we are. So this is a JavaScript console, meaning it's basically JavaScript. It already has ethers pre-installed. So all the commands that we run here, we can also run it in the console. So technically, we could deploy our contract directly in the console. What we're going to do is to attach a contract interface to the running contract, and we will start calling commands on that contract. Because right now, remember, there is a contract and min NFT already in this address, and that min NFT has an owner because it's ownable, and it has 4 tokens because we deploy with 4 tokens, and each token has a predefined amount depending on the deploy that we did, right? So let's do that. Well, with the running node and on the contract already deployed, we can basically get an instance of the contract. So it will be mint NFT await ethers dot get contract factory. The name of our NFT contract is mint NFT. Okay, so we have the contract, and now we can attach to the address that we know the contract was deployed. So this is the contract address. So we will attach this NFT contract there. So that means that we now have an NFT interface to that contract. We can run commands on that. For example, we would like to know the balance, for example. So it's an ERC 1155. That means that we have the balance of function, and this function requires the address and the token. So let's see the first address. That's the address that we use to deploy our contract. So let's use that. So in this address, how many tokens, what's the balance for this token? So I'm asking here, this account, how many of this token has token 0? It should be, oh, we need to await this. This is a promise. And it will say 1 because remember, for the first token, we said that we will have 1. So 0, 1, 2, 3. So in this case, will be 3. Right now, if we select another address, we will see that the second address won't have any tokens because we haven't transferred them, right? So balance of this other address, token 0, it will be 0. And the other function that we can execute on this contract is the NFT URI. And for this, we only need to specify the token. So let's say we want the token, the URI for the token 0, and we will get that, the IPFS, the some IPFS URL that we use in the deploy, and NFT-0. Same for 1-1, right? So our contract has the basic functionality. If we want to make a transaction, for example, so any of these methods, we're just calling the contract URI and the balance of, right? It's a contract call. The other method that we have is the set URI. Remember, this is a protected method, only the owner. But since we are running with the owner account now, we can do await NFT set URI. Oh, sorry, set URI, and we can specify the new URI. So let's say we do we move our contract metadata to some other server, some server cdn.com, and slash, so let's call it to this. So we are changing our contract's URI, right? And there you go. That's the transaction. We will have the gas price. It's really high, by the way, right? And you can see in the node that we call the set URI of that. Oh, gas use 75, so it's low. It's okay. And now, if we call the URI function on the contract, we should get a different value. For the token 0, this will be the new URI because we just changed it. Okay, cool. Once you're finished, you can just hit Command D, Control D, and you get out of the console. Cool. Let's stop our node, and we know now that our contract works, and it works in the way that we expect it to work. The next thing is to actually test our contract, and that's what we're going to do. One last thing in this episode that we will cover is how to test our smart contracts. This is really important. This is something that we should always do. We're using ERC-55 from Open Zeppelin, but that doesn't mean that we cannot test our contracts. I mean, we know that Open Zeppelin extensively test their contracts, but we should also try to execute tests for our contracts. So let's create a couple of tests for our Mint NFT contract, especially for the part of the constructor. I think that part should be tested. The part that's different is very different from the rest of the contracts that we can create. So this is the text file. By default is testing the Greeter contract. Let's change this, and we will test here the Mint NFT contract. Now, let's see the first test that we want to do. Mint NFT. So this is just deploying the min NFT contract. Remember, we need to specify a URL for the metadata and some quantities. And we will wait for this contract to be deployed, and then we will check the URI of, and we will check that that URI equals this. Well, in this case will be 0. That's the first test. So we will delete this part over here. We don't need this section. It was part of the old test. And we will call this test duty. Right, so this will be our first test. We can run it on the terminal using yarn hardhat test. And the test will essentially deploy the contract and try to run some functions against the contract. And here we go. So the URI method was successful. This is pretty cool. This is the a reporter that gave us some information about gas uses, etc. So this is pretty amazing. We can also even add a coin. I think it's CoinGecko API, and it will give us the average value on USD. So let's write another test. Let's create another test that will check that the supply of tokens in each of the NFTs, the supply of token in each NFT is correct, and they are all assigned to the centers of the deployment. So let's write that contract down, and that contract will check it. It will check deployment should assign total supply to center. Let's do this. So part of this is correct. Let me copy paste from here. So this is kind of similar test. It said we will check the balance of, and in here we need the owner, like the sender. So for that we will use the ethers get signers. So the first one is by default the owner, and that would be ether signers, right? So we have the owners. So we have the owner of the contract. This is the one that actually deploys the contract. And so we will check that the owner address on the token 0 equals to the quantity that we specify for token 0. So that will be 1. And we can run this a couple more times. I think we can use the batch balance of, probably. Or maybe we have balance of batch. I don't remember the exact. I think we can do this in a batch. Let's try to do it like this for a second. So 2 and 3. Right, this is our test. We're getting the owner of the contract, and we deploy the contract, and then we check the balance of the owner address versus all the tokens, and we should get the same amounts that we specify in the deployment of the contract. So let's run that test. Let's run that test, and let's see how that goes. And we have 2 tests that are passing. So that means that the balance is correct. So we are deploying the right contrast and with the right quantities. Um, now, let me check if this balance of function, I know this is an ERC 1155, that means that we probably have functions to do batch operations. That's one of the nice thing about ERC 1155. So Open Zeppelin, oh actually we don't need Open Zeppelin for that, it's just 1155 specification. So let's read. And batch balance, yes, we have a batch balance function. Okay, so we have balance batch receives an array of addresses and an array of IDs, and it returns an array of ints. How that works, because if we see an array of owners, let's try that. So, I mean, we know that this works. Let's comment this out and just do balances weight NFT balance of batch owners addresses, and we need to specify the IDs. So the IDs that we want are 0, 1, 2, and 3, because we have four tokens. And just for now, let's console log this, because I am not sure what is the output of this function. It seems like it's an array, but it says that it's a one-dimensional array of integers. So how those integers match with the owners. So for example, okay, so for example, given the IDs 3, 6, and 13, and the owners with the reasonable value will be it will match. Okay, it will match owner. Okay, I know how is this working. So we have to pass owners 4 times. Okay, so owner address, and owner address, and we'll get an array of balances. So yeah, exactly. So it's 1, 1, 2, and 3, and we can delete this version. Okay. So let's run the test again. Oh, right. Of course, we're getting big numbers. I guess we can use big numbers as well. So ethers big number. Do we have a big number in ethers? Yes. From. Okay, I think this is a better way to do it. Ethers big number from 1 ethers number from This is a deep equal, so it should potentially match the big number. Let's do this version. There you go. So our contract has test. So we're checking that the deployment is doing the right thing. And we need to test another thing. We need to test, and for that we will copy this test. We will test the set URL function. Okay, so we already have the owner, and we will await for NFT set URL. See, set URI. Sorry, URI, and we will pass a new URL. So we will pass HTTPS server CDN.com NFT. So we will await this transaction. Actually, we don't need the owner for this. So we will send this transaction, and then we will await that the NFT URI of pseudo will be the new URL. So this is the test that we want to run. So that will guarantee that our set URI function is working. And let's run the test again. There you go. 3 tests. Oh, we left the same name, so we should replace these two. Set URI. Okay, so our of tests are passing. Remember, when you have a smart contract, you should always test your contracts. I mean, contracts can be as simple as the contract that we just created for this Mint NFT app, or can be really complicated. I would recommend always using Open Zeppelin contracts. They're pretty good, and you can extend them and you can add your own functionality. But everything that you add should be tested. So please test your smart contracts. And this is not this doesn't pretend to be an episode on Solidity. There is a lot of resources that you can use for Solidity. I will be sharing some of these resources on the description of this video. So this is all we need for now. We already have a smart contract. We know how to create a contract project. We now know how to create the contract, compile the contract, run it on a local node, and we can run tests for that contract. There is other functionalities that we can do with Hardhat. I would recommend that you read the documentation. Hardhat is pretty good if you want to basically deploy your contracts to test network, or if you want to deploy them to the main Ethereum network, you can do that as well. And you can integrate Alchemy, you can integrate Infura. These are services that allow you to get access to the Ethereum blockchain data. So those are really good. You can integrate Coinbase API, so you can actually see the actual costs. So you're getting the cost of the USD versus Ethereum. And you can see when you run the test, you can see the cost of running those tests or running those functions, right? So that's all. So this is the transaction that we run. You see, the set URI. This is the gas that we are using. And since we don't have the USD value, we don't have the CoinGecko API. We don't have the USB value, but that's also very useful when you want to check the gas for your transactions, right? So that will be all for this episode. In the next episode, we will take in this contract, the one that we just built. Remember, in the artifacts folder, and we will using this contract, and we will deploying this contract from our interface, and that will be in the next episode. Up until then, happy coding. See you soon.